Hello class, welcome to Earthquake Engineering. I'm Jairus Giles T. Cogente, your teacher for this subject, and we will begin with the topic earthquakes and earthquake hazards. The Philippines is prone to large earthquakes and tsunamis. On November 30, 1619, we have a recorded magnitude 8 earthquake. Kadalasan, several years ago, 100 years ago, ang mga nagre-record ng earthquake, yung mga Catholic churches, kasi naapektan yung kanilang mga simbahan, nire-remodel nila, nagkakaroon ng record sa kanilang mga plaque. An example of here is in Cagayan. The churches of Lalo Tocolano collapsed. So this is in 1619. And then in February 14, 1934, you have a magnitude 7.6 earthquake and tsunami. The epicenter is this one. Ang naapektuhan, you have Vigan and San Esteban. They are affected by tsunami. Okay? So tsunami, yan yung movement ng tubig caused by earthquake. Okay? And then you have here the estimated extent of inundation in a dotted line. Inundation, yan yung tubig na pumasok o kaya yung wave na pumasok sa loob ng lupa. And then you have in July 16, 1990, ito yung isa sa mga pinakasikat na earthquake sa Pilipinas. Ang effect nito nangyari sa Baguio. You have here the hotel that collapsed, and you have the casualties in terms of dead, injured, and missing. Take note na classified sila, may dead, injured, tsaka missing. May significance yan. Ganon din sa damage. In terms of totally damaged, partially damaged. So, pagdating sa damage, meron ding kinalaman yung age ng structure, kung ano yung make ng structure, kung kailan din assign yung structure, kung ilang story ba, things like those. And yung mga attributes na yun, hindi yun connected sa intensity or magnitude ng earthquake. Now let's look at this figure. So yung epicenter, ito siya. Notice na habang mas malapit yung areas sa epicenter, mataas ang kanyang intensity. Intensity 8 is the very destructive, and then intensity 6 you have very strong, and as you go farther away from the epicenter, lumiliit din ang kanyang intensity. And then these are the impacts of the 1990 earthquake. This is the bridge, you have the school, and then you have the building nag-lean, and then another bridge na nag-collapse. And then you have another set of pictures of large earthquakes. Kapag large, these are intensities or magnitudes above 6. So you have 6.9, 6.5, and then above 7. And then you have July 6, 2017, you have a 6.5 M earthquake. And then, pinapakita dito yung mga surface rupture. Ayan. So, meron strike slip na rupture. Tapos, ito, surface rupture. And then, you have several damages. An earthquake is a weak to violent shaking of the ground produced by the sudden movement of rock materials below the Earth's surface. So take note of the word sudden. Ang ibig sabihin ng sudden ay yung hindi mo na predict na darating. Okay? So biglaan yan. Oops. Now there are two types of earthquake according to origin. You have artificial earthquake and natural earthquake. Yung artificial, this is usually man-made. So we have a nuclear or chemical explosion, and you have dynamite explosions. And then you have the natural, you have the tectonic and the volcanic. In tectonic, earthquakes are produced by sudden movement along faults and plate boundaries. For volcanic, earthquakes are produced by movement of magma beneath volcanoes. Now, why do earthquakes occur and how are they generated? Now, let's look at the cross-section of the Earth. So, sa gitna, you have the core, then followed by the mantle, and then finally the lithosphere. The lithosphere, yan yung surface. So, the Earth is compared to a section of a boiled egg. Now, let's look at the section where the convection currents are shown. Convection currents as driving force for plate movements. So, yan palang movement ng temperature. Yan yung nag-cause ng movement ng mga plates. Okay? So, may significance din yung direction ng convection currents. Okay? Yung convection currents na yan, hindi yan yung movement nung lupa sa ilalim, kundi yung movement yan ng heat generated, ng temperature from 400 degrees to 200 degrees, 2000 degrees centigrade at the lithosphere, and then you have 6,000 degrees sa inner core. Yan. Now let's look at the displacement ng lupa. So yung ridge, ayan, the plate tends to move away from each other sa location ng ridge. Tapos sa trench naman, yung plate movement naman nagbabanggaan or they move towards each other. Wherein one plate, syempre, magpapailalim siya. Okay? Now, let's look at another cross section. So, again, ito yung ridge. Okay? Tapos, you have here the fault. Okay? Ayun, trench pala, trench. Yung trench, yung mga lupa nagpabanggaan. Wherein one part, nagpapailalim siya. Okay, next. Convection currents as driving force for plate movements. And then you have here the major tectonic plates. The lithosphere, or the outer layer composed of the crust and uppermost mantle, is 60 to 100 kilometers thick. Is broken into pieces called plates that move relative to each other. Now, let's look here at the Philippines. So, mapapansin nyo merong dalawang line on both sides. Ano? Ang tawag dyan ay, yung mga lines na yan, trench yan. Ano? And, ito naman, yung lines na yan, wherein yung arrow away from each other, yan yung mga ridge. Okay? So, what is ridge? Yan. Kapag towards each other, yan ay trench. Now, look at the significance of the direction of arrows. Okay? Now, the Earth's surface is like an eggshell with cracks. And you have here earthquake in the Philippines for the past 400 years. 400 years yan yung extent ng recorded earthquake sa Pilipinas. Behind that, or earlier than that, wala na tayong record. Pero yung mga Chinese, magagaling sila sa pag-record ng earthquake. Okay? Kaya nilang mag-record up to 1,000 years earlier. Yung mga center ng mga red dots na yan, yan yung epicenter ng earthquakes. Notice that earthquakes are concentrated along or near the trenches. Okay, so this is a trench. You have here another trench. Now let's look at the Philippines. Tinanggal na natin yung mga earthquakes. Ang nagpakita dito ngayon yung mga trench. So yan yung solid line with arrows. The arrowhead shows the direction of convection currents. Yan. So yung lupa on the side behind the arrowhead, yan yung part na pumapailalim. Okay? Yan yung pumapailalim. Tapos, ito naman yung lupa na nasa ibabaw. Okay? So notice na usually yung lupa na nasa pumapaibabaw, syempre, mas mataas siya sa sea level. Something like that. So, yung mga large triangles yan, yung active volcanoes, the red lines, that is the active faults. And then the white line, continuous white line with arrowheads, yan yung active trench. Okay, so here we have the Philippine Trench. On the other side, you have the Manila Trench. Tapos, dito sa taas, you have the North Luzon Trench, which is an extinct trench. And then here, zoom natin yung part of Luzon. You have the East Luzon Trough, Manila Trench, and then North Luzon Trough. And you look at the solid red line. So those are inactive, those are active fault lines. Ito yung part ng Vizcaya, no? So merong dumadaan na active fault sa Vizcaya. Tapos meron ding mga inactive na volcano sa Vizcaya. Okay? And this is the Mindanao part. You have the inactive trench, yung Palawan Trough, active trench, the Philippine Trench, the Negros Trench, and the Cotabato Trench. And then let's look at tsunami. You have here local tsunami in the Philippines. Usually nagyayari yan sa coastline. So you have the red and green circles and yellow circles. Yung mga yellow circle na yan, yan yung tsunami with a height range ng wave 5 to 8 meters ang taas. Okay, so yan yung mga matataas. And then the red circles, yan yung location na merong tsunami up to a 3 meter wave height. Coastal areas at eastern and western margins fronting major seas and inland seas have been affected by tsunamis. So, as you go towards the center of the land, syempre, hindi naaabot dun yung tsunami. This is now the major tectonic plates. You'll notice here that the continents are connected to each other. You have South America, tapos the North American plate. Magkadikit lang sila, no? And then, you have the Antarctic plate, Australian plate, and magkakadikit sila. This is known as Pangea. From the word pan, meaning one or common or isa, and then Jaya means land. So, or that is also known as one land. So isang land lang yan. But that happened about let's look here. Let's look at this video. Play. About 160 million years, magkakadikit sila. Ayan. And finally, at present day, hiwa-hiwalay na sila. So let's look back. Yan. So this is Pangaea. It's about 160 million years ago. Naghiwa-hiwalay sila due to the convection currents. And from those convection currents, nag-form ngayon ng mga trenches tsaka ridges. Notice na yung mga trenches tsaka ridges na yun, makikita mo sa pagitan ng mga plates or continents. Now let's look at tectonic plate boundaries. Now these boundaries are located between continents or major landmass. We have lateral strike slip, divergent slip, and convergent slip. Ngayon, itong mga boundaries na yan, nangyayari din yan sa mga fault lines. Okay? So, we have lateral strike slip. Tapos, this is an example of a trench wherein ang trench, convergent yan, ano? Ito, yung one part of the soil goes beneath the other. Tapos, ito naman yung ridge, divergent yan. Ang ridge, both soils tend to move away from each other. Okay? So, ayan. Naghihiwalay sila. Ridge ang tawag dyan. Tapos, you have the lateral or strike slip. Mapapansin mo, ito, ayan. No. Yung line na yan, tsaka itong line na to, naghiwalay sila. Parallel in direction. So, that is lateral or strike slip. Now, this is an example of convergent movement. Trench ang nangyayari dyan. Usually, yung mga along trenches, nandyan din yung mga volcanoes. And then you have divergent. Yung soil naman, naghihiwalay, tinutulak pataas ng convection currents. And then you have the strike slip, an example of which is the San Andreas Fault. And yan yung movement ng earth mass. So meron silang direction ng arrow. And then this is the seismicity of the world. Yung mga red dots na yan, yan yung epicenter or location ng mga earthquakes. Ang Pilipinas, ito siya, this is also known as the Pacific Ring of Fire. Yan, yung bilog na yan, ano? Earthquake occurrences are not dispersed but concentrated along narrow zones or plate boundaries. Also, these are trenches and ridges. Now, what is happening to the Philippines? Ang pinapakita dito ay yung movement ng soil mass. So you have here a large arrow. This is the Philippine Sea Plate. And you have an arrow here coming from the South China Sea. Yan siya. And then this is location of earthquakes again. Ito yung part of the Pacific Ring of Fire. We have yung light triangle. Ito. That is inactive volcano. You have solid red triangle. That is active volcano. Tapos yung mga bilog naman, earthquake epicenters. Okay, so you'll notice na along the Pacific Ring of Fire, marami ring active volcano or solid triangle. Okay guys, so kung saan maraming epicenter, doon din located ang maraming volcano. Ito, so this is both trenches on both sides. Yung landmass galing sa plate, pumapailalim. And of course, yung Pilipinas, yan yung pumapaibabaw, kaya mas mataas siya sa water level. So, something like that. Then we have here the seismicity of the Philippines. So, you will notice here circles with different colors and different diameters. Kapag mas malaki yung diameter, yan ay magnitude 8. And if it is green, the depth is 60 to 150 kilometers. Kapag yellow, it is 0 to 65 kilometers. Ibig sabihin, yung epicenter niyan, mas mataas or mas mababaw, no? Kapag yellow, malapit siya sa Earth's surface. Kapag pula, malalim yan. Now, yung mga pinakitang epicenters na yan, this is magnitude 4 or greater. But an average of 20 earthquakes are recorded per day. Now, why 20? This also includes the smaller scale na earthquake with magnitudes less than 4. Now, in a year, there is about 100 to 150 felt earthquakes per year. And for the past 400 years, 90 ang destructive. So, yan yung mga above 6 na magnitude earthquakes. Now, what is a fault? It refers to a fracture, fissure, or a zone of weakness where movement or displacement has occurred or may occur again. A fault is said to be active. Historical and contemporary seismicity. Historical in the sense na meron siyang record, and contemporary naman kapag kilala siya, na sensationalized, something like that. And then fault slip based on displaced rock or soil units of known age and displaced landforms. Now, these are types of faults. So, ito, before faulting, wala pang tectonic activity na nangyari. And you have here, after the activity, you have normal fault, you have reverse or thrust fault, and you have strike slip fault. Then you have here the animation of different faults. Faults are fractures where rock movement has taken place and earthquakes have been produced. Active faults are those that moved in the last 10,000 years. Hindi lang ito active fault. Syempre, this also includes volcanoes. If they have erupted for the last 10,000 years, then that is also categorized as active volcano. Now, this is an example of thrust fault. Mapapansin nyo na yung degree ng kanyang displacement ay halos vertical, Pero kapag ang degree ng displacement or yung angle medyo flat, ang tawag doon ay normal fault. Okay? Pero pag matarik na, it is thrust or reverse fault. Now, this is an example, an image of a strike slip fault. This happened in the Digdig segment of the Philippine Fault. This is in Nueva Vizcaya. And then you have here distribution of active faults and trenches in the Philippines. Okay, so ito yung trench, the Philippine, and then the Manila Trench. Tapos yung solid red line, yan yung active fault. And then meron din tayong mga dashed line. Ito. Tapos meron din tayong mga broken lines. Now, how do we measure the strength of an earthquake? It is measured in terms of magnitude and intensity. Kapag medyo scientific ang pinag-uusapan, magnitude ang ating gamit. Okay? Because it is in terms of energy. Pero kapag ang pag-uusapan natin yung degree ng damage, ilang tao ang namatay, ilang buildings ang na-damage, it is in terms of intensity. Okay? Because intensity is effect, perceived, or felt strength at the surface. Yung magnitude, walang kinalaman dito yung number of buildings located in the area or number of people located in that area or above the focus. Okay? So, focus is the center of energy released during an earthquake. Ang measure niyan, yan yung depth from the center, from the epicenter or from the top. Okay? And then you have here the fault. And then this is the equivalent of earthquake energy in terms of kilograms of explosive. So, magnitude 10, it is 56,000 million, billion, trillion, quintillion, 56 quintillion kilograms of explosive. Yung pinakamaliit na magnitude, this is 2. Ang katumbas niyan ay 56 kilograms of explosive. Somewhere in between 2 and 3, you have 2.5. Ang katumbas niyan ay moderate lightning bolt. Okay? Also, mapapansin nyo ang occurrence ng maliit na earthquake, magnitude 2, mas marami ang kanyang occurrence per year worldwide. It's about 1 million. Siyempre, habang tumataas din ang magnitude, ang occurrence niya lumilit din. For example, magnitude 9, isang beses lang sa isang taon ang kanyang occurrence. Okay? And then, this is a graphic representation of the strength of an earthquake in terms of intensity. Intensity is the perceived strength of an earthquake based on relative effect to people and structure on the Earth's surface. Okay? This is relative effect to people and structure. Now, what is meant by relative effect to people? Yung mga tao, maraming klase yan. Unang-una, in terms of age, meron dyan yung mga old people, mga senior citizen. Ibig sabihin, pag nag-earthquake, madaling maapektuhan yung mga senior citizen kasi di na sila makagalaw, di ba? Tapos, susunod yung mga teenager, working class. Siyempre, pag dumating ang earthquake, yung mga teenager na yan, madali lang silang lumikas. Okay, so that is relative effect on people. And how about structures? Kapag ang structure gawa yan sa simento, siyempre pag dumating ang earthquake, mas matibay yan, di ba? Also, kapag ang structure, it is engineered, ibig sabihin, meron siyang plano, ginawa niya ng structural design, siyempre, makakasustain yan ng magnitude 7 na earthquake. Pero kapag ang building mo, designed yan maybe 20 years ago, okay, so that is probably like, or maybe 50 years ago, that is pre-code. Ibig sabihin, hindi masyadong engineered ang kanyang bakal. So, mas prone to damage yung mga ganong characteristics or attributes ng structure. Okay? It is generally higher near the epicenter, reported as Roman numerals. Okay? Yan. So, you have Roman numeral 1, 2, hanggang 10. And then we have here the magnitude, or that is the energy. Magnitude is a measure of the total energy released at the earthquake's point of origin, that is also known as focus. It is below the Earth's surface based on information derived from a seismograph reported in Arabic numbers 6.3, 7.5, something like this. And then you have the Phoebos Earthquake Intensity Scale, or BEIS. So merong 1, 2, 3 Roman numerals, ano? Number 1, it is scarcely perceptible. Ibig sabihin, yung iba nararamdaman nila, yung iba hindi nila nararamdaman. Okay lang, kagaya tong mag-ina, wala silang, hindi nila napansin. Pero yung tatay nila na nakahiga, napansin nila may gumalaw. Ha? May earthquake, hindi nyo ba naramdaman yan? Parang ganon. Okay. And then, number 2, slightly felt. Ayan, nag-earthquake na. Hindi lang isang taong nakaramdam. Pati na rin si Mrs. naramdaman na niya. Tapos, number 3, weak. So, ibig sabihin, medyo lumakas na ng konti yung movement. Ano? Naramdaman na lahat. It is felt by many people indoors, especially in upper floors of buildings. Vibration is felt like one passing of a light truck. Okay, pag nasa loob ka ng bahay, parang may dumaan na malaking truck sa labas. That is weak. Or intensity 3. Also, you will notice here na yung mga hanging pictures mag-start na siyang gumalaw. And then at intensity 4, syempre, gumalaw na rin yung picture frame. Tapos, mas malaki na ang kanilang pag-swing, yung mga picture frame. Yung mga gamit mo sa loob ng bahay, nag-umpisa na ring gumalaw. And then, at intensity 5, this is now strong. Yung tubig mo, mag-umpisa na yung gumalaw. Magpo-form na siya ng motion. You bet that's the time that you start to go out of your building. And then at intensity 6, very strong na yan. Okay? Mag-umpisa na ang destructive. Okay? Dito na mag-start din ang mga landslide. This is known as earthquake-induced landslide. Many people are frightened. Many run outdoors. Some people lose their balance. Motorists feel like driving in flat tires. And then intensity 7, it is now destructive. Yan. Yung mga bagay sa loob ng bahay, mag-umpisa na yung magkandahulog. Also, mag-umpisa na ring magkaroon ng major landslide. Okay? Also, magkakaroon ka na rin ng sand boils tsaka liquefaction. Yan yung intensity 7. Ang ibig sabihin ng sand boil, yung lupa may lumalabas ng tubig. Tapos liquefaction naman, yung lupa nagiging saturated na siya in the sense na yung mga structure sa ibabaw ng liquefaction lumulubog. Yan ay intensity 7 na. And then we have very destructive or intensity 8. ang bridge mo nag-start ng mag-collapse, and then meron ka pa rin sand boil tsaka liquefaction, and then 9, you have devastating. Yung mga buildings mo nag-start ng mag-collapse, okay, pero hindi pa siya totally collapse. And then finally, at 10, it is completely devastating. Yan. Ang mga structures mo, collapse na siya or totally collapse. Ibig sabihin, tumba-tumba ng mga buildings mo. Ang mga transmission lines mo, wala na rin. Practically all man-made structures are destroyed. Now, ano ang role natin bilang mga civil engineers? First, kailangan ang structures natin kayang mag-sustain ng magnitude 7 to 8 na earthquake, or that is category A or type A na earthquake. Okay, also as structural engineer, dapat alam natin ang location ng building relative to a fault line. Okay? Siyempre, pag mas malapit sa fault line, yung fault line, ang tawag dyan ay earthquake or seismic generators. Ibig sabihin, mas mataas ang intensity, mas mataas ang magnitude habang lumalapit sa fault line. Kaya dapat yung design mo mas malakas, mas matibay, mas matapang. Okay. Now, what's the difference between Philippines and Saudi Arabia? Yung sa Saudi Arabia, sa Dubai, hindi sila prone sa earthquake activity. Kaya mapapansin mo, tataas ng mga buildings doon. Kasi, mababa lang ang kanilang seismicity doon compared dito sa Pilipinas. Okay, let's look here. So this, at the epicenter, you have intensity 8, and as you go farther away, bumababa rin ang kanilang intensity. Now this is the damaging effects of earthquake. This is probably intensity 10, yan, totally collapse. This is siguro nasa 8 and 9. Kasi may mga tumatayo pang building. Ito. And then, look at this one. Ayan, oh. Ito mga kahoy. Mga light materials. Samantalang ito, this is concrete or engineered structures. You look at the light materials or semi-concrete wood structures. Sila ang mas na-damage. Ano? So, may contribution ang mga attributes or characteristics ng structures. Okay, so yan. And dyan papasok ang intensity. Now let's look at this video. Yan. Yan. Anong level na yan, no? O, yan. Lumakas lalo. Naging intensity 8. Something like that. And that is the 1995 Kobe earthquake. The observations, yung mga tao, difficult to stand, frightened, rumbling sound, and then small objects. They fell and overturned, and then rocks with wheels. Nag-start na siyang mag-move, yung cabinets. Natumba-tumba na, and then standing vehicles, gumagalaw na siya, obviously. Yan ang observations during strong earthquake. At least intensity 7, at least intensity 6, and then intensity 4. Yan ang nararamdaman ng tao at these different levels of intensity. At intensity 4, meron kang maririnig na rumbling sounds or things like that. At intensity 5, small objects, nagtutumba-tumba na. At intensity 6, ang mga cabinet na may gulong, gumagalaw na rin. At 7, cabinets, aside from nag-move na, nagtutumba na. Yan yung mga cabinets na walang gulong, no? And at intensity 5, yung mga sasakyan are also moving. Okay? Now, what are the factors that primarily determine what we feel in an earthquake? First, the magnitude. We feel more intense shaking from a big earthquake than from a small one. Yan. A small one, ito, magnitude 7 lang, tapos habang lumiliit, magnitude 5.8, pero pag magnitude 9, it is a big earthquake. Now let's look at the magnitude. At 5.8, at 5.7, ang increase niya, it is more than double, parang exponential pa nga, no? At 7, and then at 9, exponential ang kanyang increase. And then factors, still this, let us consider the distance from the fault. Earthquake waves die off as they travel through the earth, so the shaking becomes less intense farther from the fault. So ibig sabihin, habang lumalayo yung structure mo sa epicenter or sa fault, is mas maliit ang iyong nararamdaman na movement. Now we have here a video.
The motion of similar buildings on different bedrock will be exaggerated to show the arrival of compressive P, shearing S, and rolling surface waves from a regional earthquake. 3 consecutive seismograms will show the changing frequency and amplitude resulting from the change in rock type. The initial P wave arrives with a compressive bump and rarely causes much damage. The slower shearing S wave introduces a side-to-side motion that can throw loose objects to the floor and may crack walls. The rolling surface waves are the most damaging in unconsolidated sediment. As surface waves enter the sedimentary layer, they slow down and increase in size, causing buildings to roll. If not engineered for the motion, they can crack and tumble. But even a well-engineered building can sink during the shaking and liquefaction of underlying wet sediment. The first seismogram from the Pink Building on solid ground shows low-amplitude, high-frequency waves. When the waves hit softer ground, they slow down and increase in amplitude. It's this higher slowing roll that is so destructive during an earthquake.
So, merong bagong terms, ano? So, you have the P wave, the S wave, then you have the amplitude, and then frequency, things like those. We will tackle them later on. And then 2 variables affect damage during earthquake. Number 1, intensity of shaking, and 2, engineering. No? Engineering, yan yung design ng structure. And then here we have the Philippine Seismic Network. Ito ay mga offices ng PHIVOLCS na merong mga sensors sa loob. So we have one in Magalang, Pampanga, in Davao, And in the entire Philippines, merong 36 manned stations. Ibig sabihin, merong mga tao sa loob. And then we have 51 unmanned stations. Ito yung mga automatic sensors na kapag may na-sense na motion, automatic sila na nag-send ng signal. Or, meron din silang record ng motion. And that is the Philippine Seismic Network. Ibig sabihin, connected sila sa main office. And then this is the office. You have the data receiving center. This is located sa Diliman, sa PBOX. And then also, aside from the Philippines, meron din silang global seismic network. And here we have the disaster losses. So you have life loss or injury, damage to buildings, infra, properties, equipment, displacement of people, loss of lifelines, water, energy. Kapag lifeline, ito yung mga transmission lines. Now, this includes electricity, ayan, pati tubig, kuryente, communication, things like those. Lifelines means anything that connects one place to another place where people are located. Okay? So damage to or interruption of food supply, loss of public and other critical services like communication, and electricity, loss of business or revenue from business interruption, disruption of economic development, and damage to the environment. And these are all losses. Now, losses is also connected to risks. And then we have disaster resilience goals. Okay guys, somehow ano na tayo? This is not connected in a way sa earthquake engineering, pero as engineers, kailangan nating tumulong sa mga ganitong situations kasi tayo yung nagde-design ng building. Hindi lang yung structure ang pinaprotektahan natin, pati yung mga occupants ng structure, and that is yung mga buhay ng tao. Resilience is simply the capacity to recover quickly from difficulties. Okay? So, disaster resilience goals. Kung paano sila makabawi, you should have reduced various losses, lives, properties, lifeline, yung mga risks, ensure effective and efficient disaster response, continuity of government, business, and critical public service, and then finally, fast recovery or rebuild better. So, dapat yung mga tao prepared sila para sa pagdating ng malaking earthquake, which nobody knows when. Disaster imagination. Imagination is more important than knowledge. That is from Albert Einstein. We need to have science-based hazard and risk scenarios for extreme large-scale events. Now, you look at the term hazard and risks. Okay. Yung hazard, darating tayo dyan mamaya. Tapos yung risk naman, yan yung meron sa lugar in concern. Okay. So, that includes people, structures, buildings, so forth and so on. And you should have appropriate preparedness and response in time of disaster. Ngayon, yung preparedness, yan yung degree ng preparation ng tao before sa disaster. Okay? Gaano sila kahanda? Ilan ba ang naka-reserve na meron pa silang ambulance, things like those. And then yung response naman, paano sila magre-recover after nung disaster. Okay? Also, response, importante yan. And then we have key actions for disaster risk reduction. Itong DRR, ito ang nauuso ngayon. So, meron tayong DRR sa barangay, meron tayong disaster risk reduction sa munisipyo, sa probinsya, and of course, national. Meron tayong disaster risk reduction. So, first, you should know hazards and risks. Again, meron na naman yung hazards at yung risks. And you should know how to monitor and then warn and disseminate information. This is communication. And respond properly and timely. This is preparedness, mitigation, response, recovery. Okay, you look at the word mitigation. May ibig sabihin yan. Yung term na mitigation, this is sikat na sikat yan sa disaster. No? Now, let's look at earthquake hazards. An example of earthquake hazard is ground rupture. Ito yung paggalaw ng lupa. And then we have another hazard, tsunami. And then you have ground shaking. Ground shaking, yan na yung tuloy-tuloy na paggalaw ng lupa. Hindi lang isang beses gumalaw, kundi may back and forth movement yung ground. Okay? So may frequency ang movement. And then you have liquefaction. Another form of liquefaction is yung sand boil, ano? Yung lumambot yung lupa due to saturation. Tapos we have landslide. Ang landslide, dalawang klase yan. You have earthquake-induced landslide tsaka rain-induced landslide. Yung rain-induced, kapag kumulan ng malakas, may bagyo, nagkakaroon ng landslide. But not necessarily on earthquake. Okay, kapag earthquake, that is earthquake-induced. And finally, you have fire, also known as secondary hazard. Nagkakaroon ng fire dahil yung mga wires mo na short, ganun. Okay, mga LPG ng tangke ng LPG, umabagsak, yan ang cause ng mga fire. And this is known as secondary hazard. Yung primary hazard is natural. You have ground rupture, tsunami, ground shaking, liquefaction, and landslide. Yung fire is only secondary. Now let's look at active faults and trench in region 2 and the vicinity. So ito yung solid red, yan yung active fault line, and then you have the trench. Ang significance nito is kapag yung building mo na dine-design malapit yan sa fault line, you have to design it more stronger. And then we have ground rupture. Okay, creation of new or the renewed movements of old fractures, oftentimes with the two blocks on both sides moving in opposite directions. So strike slip yan, ano? And then you have ground rupture. Yung ground rupture, kasali dyan yung ridge, trench. Ito, nag-split yung lupa. They moved away from each other. Ito, tingnan mo. Parang ridge effect din. Okay? So, yung lupa mo, they also moved away from each other parallelly or parallel. And then, ito naman, fault ito. Yung lupa mo tumaas. This happened in Bohol in 2013. Mahaba yan, ano? And then this is still in Bohol. The 2-kilometer long continuous surface rupture of the North Bohol Fault in Inabanga. Now, look at this building. Mapapansin nyo, nakatayo pa siya. Pero it is very near to the fault line. Yan. May significance ang distance niyan. And ground rupture risk reduction, avoiding the effects of ground rupture. Okay, risk reduction is simply avoiding the effects. First, you avoid construction of structure on top of an active fault. You look here. Papansin nyo yung structure sa ibabaw ng fault. Ayan, nagiba. House or building should be at least 5 meters away from the trace of the fault. Now, let's look here at the definition of mitigation. Mitigation is the action of reducing the severity, seriousness, or painfulness of something. Now, so, ano na yung mga terms natin? You have resilience, the capacity to recover, and then you now have mitigation, the action of reducing the severity. So, mitigation means action. Okay. Now, hazard and risk information through web application is PHIVOLT's Fault Finder. So, i-download mo yan sa cellphone mo. Pwede yan. phivolts.dost.gov.ph. May significance yan. As an engineer, ako as a designer, ginagamit ko ito. Kasi, nakukuha ko yung distance nung location ng building to the nearest fault line. Okay, so may ibig sabihin yan kapag 5 kilometers yung distance, mataas ang near source factors mo. Kapag greater than 5, mas bumababa ang NANV or yung near source factors. Kapag greater than 10, 1 na lang ang iyong near source factors. Things like those. Ibig sabihin, kapag lumalapit, tumataas din ang NANV mo. Ibig sabihin, palalakasin mo yung base shear ng building para mas matapang ang mga bakal mo. In a way, kaya niyang mag-sustain ng mas malakas na movement. Okay? So, dati-rati, sinusukat namin ang distance using ruler from the NSCP book. Ngayon, mas accurate na kasi GPS-based yung cellphone, siya na magsasabi kung ilang kilometers. Ayun, this is 2.9. And then we have number 2, ground shaking. So, ito, yung P waves tsaka secondary waves. Kapag P wave, it is the up and down motion of a building. And then you have the S wave. You have the lateral movement of the building. Okay? P waves are transmitted as a compressional disturbance, while S waves are transmitted as transverse disturbance. Kapag sinabing transverse, it is 90 degree from the direction. Ayan. So, kung ito yung source mo, pataas, yung motion mo ay horizontal. Kapag yung source mo, ito, yung motion mo, pataas pababa pa rin. Okay? So, that is P. Now, this is intensity 7 in 1995. This is from Kobe, Japan. Ayan siya. So that happened in January 17, 95 at 5:46 in the morning, and that is magnitude 6.9. Approximately 6,434 people dead and 36,896 injured, 200,000 buildings damaged, 300,000 people were evacuated, and $200 billion in damage. And then another hazard, you have ground shaking. Okay, this is in California, this is in Baguio 1990, and then in USA and Nepal. Now let's look at the structure response of a building. In terms of magnitude, take note magnitude 1, yung konting tao lang ang nakakaramdam, no? Kapag magnitude 10, that is total collapse. Magnitude 2, siguro 2-3 nang nakaramdam, things like those. Okay? So let's play this. But before that, let's look at the significance of these two structures. Yung first structure, ito, low rise, meaning 20 meters or less ang height. Tapos ito, or this is mid-rise probably, ano? And then ito, mataas na to. High-rise na siya. Tapos meron ding body of water dito, reservoir. Now let's play. See? This is another video. Ang tawag dyan sa mga technique na shake table. Okay, so mapapansin nyo in the background may mga Pilipinong nagsasalita. Ang ginawa nila, nagdala sila ng mga hollow blocks sa Japan, ano? Mga taga Peebles yan. Tapos nag-set up sila ng dalawang structure. So this is a common house construction dito sa Pilipinas using concrete hollow blocks. Ito, yan yung unengineered construction, ano? Yung tipong konting bakal, walang beams and columns, things like those. Samantalang itong kabila, ito yung may engineering component, ano? So mapansin mo sa taas meron pa siyang load. Okay? This is engineered. Mas nakasustain siya ng na-sustain niya yung devastating effects ng earthquake. How safe is my house? So this is self-check for earthquake safety of CHB houses in the Philippines. So you have 1. Ko-consider mo sino yung gumawa ng building mo. Foreman ba o engineer? Number 2, another question. How old is my house? Is it before 1982 or after 1982? Ang ibig sabihin nito, yung 1982, dito palang nag-umpisa yung building code requirements. And number 3, what is the shape of my house? Is it regular or irregular? So, ang ibig sabihin niyan, kapag irregular yung building mo, mas prone siya sa sa damage. Kasi, yung distribution ng stresses mo is irregular. Okay? Yung force mo, magko-concentrate siya dito sa smaller part. So, things like those. Number 4, has my house been extended or expanded? You look here. Ito yung original design mo. Siyempre, ginawa yan ng engineer. Ganito lang dapat ang gagawin mo kasi yan lang ang kasya sa budget mo. Okay? So, ibig sabihin, para maka-economical, ide-design niya yung beams and columns saka yung bakal for this structure only. So, kapag in-expand mo yan, ibig sabihin, mas bibigat yung building mo. Di ba? And, mas mataas ang kanyang risk sa damage sa earthquake. Number 5, has my house been damaged by past earthquake or other disasters? Okay, kapag yung building mo naka-experience na yan ng disaster such as earthquake or flooding, may mga components yan sa loob na nai-stress. Hindi mo alam, baka yung bakal mo sa loob nag-elongate na. Tapos yung wires mo sa loob, baka nag-stretch. Kapag nag-stretch, lumilit ang cross-sectional area, some things like those. And then finally, number 6, what is the thickness of the wall? Yan. Pag exterior wall, dapat 6 inches. Kapag interior wall, dapat 4 inches. Things like those. And then 7, are there steel bars used on walls and floors? Importante yan. Dun sa demonstration kanina sa CHB house, yung model A, yun yung walang bakal, yung model, yung model na nagtumba-tumba, yun yung building na walang reinforcement, or that is unengineered. And then yung model na nakatayo pa rin, yun yung merong rebars sa hollow blocks. And then number 8, are there walls more than 3 meters wide? Yan. Ibig sabihin nito, kapag yung wall mo ay higit more than 3 meters na, dapat meron na siyang poste. Kasi ang hollow block walls mo, kapag 3 meters or less, kaya niyang mag-sustain ng lateral displacement. But kapag 3 meters or more na, dapat meron na yang poste in between. Okay guys? So in short, ang common idea dyan, as a designer, gagawa ka ng building plan, dapat yung poste mo, kapag ang spacing ng poste mo is 3 meters or 4 meters. Ako generally, ang pagitan ng mga poste ko, nasa 4 meters, ganun. Minsan, kaya ko pa mag-design ng 5 meters na poste. Pero obviously, kapag ganong 5 meters na, ang malamang walang wall yan sa gitna. Okay guys? Number 9. What is the roof of my house? Is it light or is it heavy? Yan. Siyempre, kapag yung roof mo mabigat, that is comparable to parang naglagay ka ng barbecue stick, tapos naglagay ka ng weight sa taas. Ano ang mas magdi-displace? Siyempre, yung mabigat ang weight sa taas. Okay? So, that is one of the considerations. And then, number 10, what is the foundation of my house? Is it reinforced concrete? Or it is simply nakapatong lang sa buhos? Ano? Again, papasok dito yun, is it an engineered construction? Number 11, what is the soil condition under my house? Okay, is it hard soil? Is it soft soil? Kapag hard ang soil mo, okay, yung vibration mo, ano yan, mataas ang frequency. Pero kapag ang soft soil mo, baka maliit ang frequency, pero very prone ka man sa liquefaction. So, things like those. And kapag ang soil mo ay soft, syempre kailangan mo ng mas malaking footing area. Okay? Next, finally, you have 12. What is the overall condition of the house? Is it A, good, B, is it poor condition, and C, it is not clear or unknown. Now, you look at the rating scale. It is A, B, C. Para sa mga gumagawa ng survey, pwede mong gamitin ito, no? And all of these questions can be done by visual inspection alone. Kapag nasa labas ka ng building, check ka na lang ng check. Hindi mo na kailangan pang magtanong sa loob ng building. Hindi mo na kailangan kumatok. Okay? So, that is rapid evaluation, no? So, paspasan yan. Now, this is ground shaking map of Ilocos Norte. Yan yung red. Ibig sabihin, mataas ang kanilang vulnerability. And then, this is the 6.5. Now, yung color coding yan, kapag pula, mataas ang magnitude. And then, as you go farther away, nagiging green, nagiging blue, bumababa rin ang kanyang magnitude. Okay? So, yun. This is red. This is 6.5. And then, that is the epicenter. Oh, this is in terms of intensity. PEIS. Okay? Yan. Then, this is 6.9. This is a simulation only. Ang ibig sabihin ng simulation, gumamit ka ng software, and then, ipinasok mo yung mga nagamit mong data. Yung data na yun, yun yung mga questions 1 to 12. Ipinasok mo sa software, magge-generate ngayon si PBox, no? ng intensity. So, being 8, very destructive, up to 5, strong, able to cause panic. And that is in the areas Ilocos Sur, La Union, something like that. Umabot pa yan sa Nueva Vizcaya. Okay? Ayan o. Dito tayo, Nueva Vizcaya. Part of Nueva Vizcaya is green. Yan. And then, this is an simulation scenario. Ibig sabihin ng scenario, mag-a-assign si PHIVOLCS ng epicenter anywhere in the Philippines at mag-generate siya ng parang simulation ng damage, no? Simulated intensity of ground shaking. So, kapag dito man nilagay yung epicenter, tumataas din ang damage or intensity sa Vizcaya. Ayan. Naging, ano na tayo? Intensity 6 na. Compared kanina, intensity 6 pa rin. Yan. Ito. Nung nandito sa Ilocos Norte, intensity 5 lang tayo. No? Habang lumalapit, tumataas din ang intensity. Ayan, okay? Tapos ito naman, yung epicenter mo nasa labas. Ang delikado dito ngayon is yung coastline mo. Magkakaroon dito ng tsunami. Okay? Or inundation. Yung water level mo, tataas, aabot yan papasok yan sa loob ng lupa. Now, number 3 hazard. You have liquefaction. Liquefaction, it is a process where particles of loosely consolidated and water-saturated deposits are rearranged into more compact state, squeezing water and sediments towards the surface in the form of sand fountain and creating a condition resembling quicksand. Ayan. So, eto, kapag yung lupa mo nag-move, okay, yung mga heavier particles bumababa, tapos yung mga lighter particles tumataas, and then yung water level mo syempre nadi-displace, something like that. And then let's take a video. Ayan siya. This is sample of liquefaction. See? Yung building, lumulubog siya dahan-dahan. Loose water-rich sediments behave like liquid during strong ground shaking. Sediments are rearranged into a more compact state. So these are several images of the effects of liquefaction. Ayan. Yung soil bearing capacity bumaba, so nag-displace yung foundation mo. Ayan, natumba yan. Mapapansin mo, yung building dito sa kabila, hindi siya ganong natumba. Okay, konti lang. Samantalang ito, 3-story, natumba siya. Okay? So, ano kaya ang less engineered dito na building? Yan, things like those. Or, gumawa ba ito ng boring test? Things like those. So, sa structural engineering, marami ka ring hindi na-foresight. For example, kailan kaya magkakaroon ng earthquake? Ano ba yung nasa ilalim ng lupa? Is it limestone? Solid ba ito na bato? Things like those. Okay? Nagkaroon nga tayo ng boring test. You know? Kasi dito sa Solano, Vizcaya, kapag 3 meters na yung building mo, nire-require na nila ng boring test. And that is provided by geotechnical services. Then these are still effects of liquefaction. Ayan. You'll notice here na yung foundation ng structures mo lumulubog. Obviously, yung structure sa superstructure lulubog din kasi bumaba yung substructure mo . And then you also have lateral spreading. That is still effects of liquefaction. Yan. Parang ridge ang effect. Then you also have ground settlement. And characteristics of liquefaction-prone areas. These are localities prone to liquefaction are letter A, water-saturated or shallow water table, which is low-lying. Sa Solano area, mababaw ang water table, no? Kaya prone ang Solano sa liquefaction. Letter B, have loose, unconsolidated, sandy or silty deposits. This includes riverbanks, abandoned rivers, floodplains, coastlines, swamps, reclaimed areas. Also, yung along Magat River. So, prone din yan sa liquefaction. Okay? So, this is a hazard map. Yung pula, pansin nyo, this is prone to liquefaction. This is along the coastline. And then we have earthquake-induced landslide. This is hazard number 4. It is slope failure in steep or hilly slopes. Yeah, this is taken in Nueva Vizcaya in 1990. And then downslope movement of rocks, soil, and other debris, commonly triggered by heavy rain and strong earthquakes. So you have rain-induced and earthquake-induced landslide. Ang characteristic ng landslide, yung mga bato na mabibigat, nagro-roll yan sa baba. So yan. So you have erosion, burial, blockage. This is road destroyed by quake-triggered landslide in China. So, once in a while, kapag tag-ulan, going to Manila, or dun sa Kayapa, going to Baguio, meron akong na-encounter na mga landslides. But those are rain-induced only. So, as engineers, kaya rin nating mag-design ng mga protection works para mabawasan ang landslide. And then this is at Solongon, La Libertad landslide. This is in Zamora, Gihulngan landslide. This is from Negros. Naka-experience sila ng magnitude 6.9 noong 2012. So, intense shaking, ang ibig sabihin nung intense yung mabilis, tsaka yung steep slope, and that will produce a landslide. And then heavy rain plus intense shaking plus steep slope again will produce a stronger landslide. Pero bibihirang magkasabay ang malakas na ulan tsaka earthquake. And then this is a giant sea wave due to large scale displacement on the sea floor. So, tsunami yan actually. Japanese term meaning harbor waves. This is a series of waves generated by various geological process. And then, generators of tsunami. Number 1, you have earthquake. Yan, kapag nagkaroon ka ng trench, yung lupa mo, pwedeng tumas, pwedeng bumaba. Siyempre, magkukos yan ng wave. And then, you have less commonly by on land or submarine landslides, and then very rarely you have meteorite impacts, and infrequently by underwater volcanic eruptions. So we have here tsunami versus other types of waves. You have tidal waves and waves due to strong winds. Tidal waves are gravitational attraction between the earth and other heavenly bodies. So, mapapansin nyo kapag gabi na, yung level ng water mataas. So, may effect din palang gravity, ano? So, and then waves due to strong winds. Mapapansin nyo kapag, syempre, bumabagyo, bawal mag-swimming, bawal pumalaot, yan. Tsunamis run quickly over the land as well as a wall of water, and here tidal waves, and these are wind waves, come and go without flooding higher areas. Then tsunami generation. Letter A, tsunamis are commonly generated in subduction zones under the ocean where two plates collide, with one plate A moving down under the other. And then B, when plates get stuck, the overriding plate gets distorted. And C, stuck area ruptures triggering an earthquake and pushing up the ocean floor and seawater. This starts the tsunami, which moves in opposite directions. A tsunami travels outward from the source region as a series of waves, and as it travels, it spreads. So, from elementary or high school physics, yung definition ng wave, yan yung may crest, yung may throw, yung may cycle, things like those, no? So, tsunami speed depends on water depth. So, kapag yung depth mo malalim, faster in deep water, mas mabilis ang tsunami sa mas malalim na tubig, and slows down as tsunami hits the shoreline, about 30 to 50 kilometers per hour. And then a tsunami moves faster in deeper water and slower in shallower water, causing their amplitudes to greatly increase in shallow water. So, meron na naman yung term na amplitude, ano? So, tsunami height depends on water depth too. Short in the deep parts of the ocean, which is less than 1 meter, and then becomes taller as tsunami hits the shoreline at less than 30 meters. Yan. So, you will notice yung height ng wave, ano? Habang yung depth ng water mo nagiging mas shallower, mas mababaw, yung height ng wave, ng tsunami wave, tumataas. Okay? Tapos yung force mo, lumalakas din. Yan. So, ito yung height dito. Malit lang. Dito, mas mataas. Pinakamalapit sa coastline, yan na yung mataas ang wave. Yan. Which is true. Nakikita natin yan sa TV. And then these are the damage and effects. This is in Japan. Flooding of coastal areas, drowning of people, damage to properties. Ito. These are pictures taken by Renato Solidum. Siya yung director ng PHIVOLCS. Na-displace yung mga vehicles, pati barko na-displace. Yan. So these are done by waves, ano? Siyempre, ito galing yan sa dagat, itinulak ng tsunami due to inundation. Inundation, yan yung pagpasok ng tubig sa loob ng lupa. Ganon kalakas ang wave. Yan. So, mga barko pumasok sa loob ng lupa. Mga rails na displace. Pumasok din sa airport. Yan. And then, forceful impact on houses, buildings, infra, erosion, and destruction. This is also done by tsunami, wave effect. And then, this is an effect. Ito, disaster building yan, no? Still in Japan. Ayan. Ito, yung clock. Ito rin yung clock sa labas. And then, look at the effect of tsunami. This is before. Ayan. Mapapansin nyo, yung land mass, buo siya. May mga structures pa siya. And then, after, na-wash out yung mga structures. Ano? Ayan. Wash out. Tapos, of course, you have death. Then we have the Philippine Tsunami Information. This is very useful along coastlines. So, merong advisory level. Ayan. Then, we have the hazard map of Ilocos. Obviously, along coastline, very risky yan. And then, also, hindi lang earthquake ang minomonitor ng PHIVOLCS, pati tsunami hazards din. Okay? Minomonitor din yan. So, meron silang mga sensors that is sparsely distributed along the coastlines of the Philippines. You have tsunami sea level monitoring. Ayan, bigay ng JICA, gawa ng DOST. GIA. GIA is grant in aid. JICA is from Japan. Ito, tide gauge. Kapag tumaas yung water level, nagsesend yan, nadedetect yan nung sensor, and then it will send signal. Ayan, solar panel yan. Ano? Also, they have wet sensors distributed along coastlines. Yan. So, pag na-detect ngayon ng sensor, magsesend siya ng signal sa transmission station, and then si transmission station naman siya ang magsesend via satellite papasok sa PHIVOLCS office. Now, there are two types of tsunamis. You have local and distant. Kapag local, gawa yan sa trench, Philippine trench. Kapag distant naman, away or outside of the Philippine trench. No? Siyempre, kapag local yan, meron kang lead time na 2 to 5 minutes to 1 hour. Ang ibig sabihin ng lead time, magbibigay ng warning si PHIVOLCS, and then within 2 to 5 minutes or 1 hour, doon darating yung arrival ng tsunami. So, in a sense, something like that. Kapag distant naman, syempre, mas malayo. You have 1 to 26 hours lead time. So, in a sense, yung lead time, yan yung oras or number of minutes for you to evacuate. Now, what are the warning mechanisms in place? So, first and foremost, you have PHIVOLCS, you have the Community-Based Disaster Risk Reduction Management Office. So, bawat barangay, meron niyang kanya-kanyang DRR office. They must rely on natural signs such as moderate to intense shaking in coastal area, and they should be aware of rapid sea level drop or rise and unusual sounds. And then you have locally generated versus distant tsunamis. Locally generated, so these are from Philippine trench lines. You have very short lead time, while distant tsunamis, walang naramdaman na earthquake. It may take hours before reaching the Philippine coasts. Yan. This is a sample of tsunami. Ulitin ko lang. Yung dito, nag-generate yung epicenter somewhere here. Meron kang lead time, several hours to reach the Philippine coastline. So, yan ang kanyang simulation. Yan. So, yan yung wave. Tsunami wave. Natural signs of an impending local tsunami. So, pag meron kang naramdamang earthquake, obviously, pag nakatira ka sa near the coastline, okay, so that is shake. Then you have unusual sudden rise or fall of coastal waters. Ayan, mapansin ninyo yung tubig biglang lumayo. Nag-drop yung level of water. And then you have exposure of corals, underwater rocks, and marine life, and unusual sound. Yan, may dumadagundong. Ibig sabihin, may impending local tsunami. And then you have hazard and risk information through application. So again, si Feebles, gumawa yan ng app which is GeoRisk. It is a web GIS-based portal, enables the public to view and collate hazards and risk maps. So dalawa na ang app natin kanina, yung Fault Finder tsaka itong GeoRisk. So yung Fault Finder, para naman sa mga fault yun. Itong GeoRisk, para sa tsunami. And then you have the TEWS or TEWS, Tsunami Early Warning System. Gawa din ito ng Feebles. Okay, so these are basically sensors at stations, no? And now let's go to preparedness activities. Ito yung mga mag-meet yung barangay, tapos i-meet nila yung mga stakeholders, ano ang mga gagawin during strong earthquake, ano ang mga signs ng tsunami, ano ang mga gagawin, ano ang mga preparation na gagawin, meron bang evacuation center, not necessarily wait for the siren but concentrate on evacuation procedure. Okay, these are the natural signs: shake, drop, and roar. And then you have early warning system. So patingting system, yan yung bell ng ice cream, patingting ang tawag nila dyan. And then yung church bells, that is also one form of warning system. And ito naman tsunami rin. So this is a picture of, yan yung height, yan ang inabot nung tsunami, ganyan kataas. Then she didn't hear the PA anymore, but she saw natural signs. Ano na yung natural signs na yan? Yan yung shake, drop, and roar, draining river, and tsunami crest. Okay? So, at this location, yung water level mo bumaba. Things like those. No? And then we have a record of destructive earthquakes in the Philippines. You have magnitude 7.5 in Lanao, 7.3 in Casiguran, and 7.3 in Baler. Tapos 1990, you have the 7.8 in Luzon. Now, how do we prepare for the big one? How do we prepare for earthquakes? How do we prepare for hazards? How many hazards do we have? 5. May ground rupture, ground shaking, may liquefaction, merong tsunami, ano pa ba? Merong fire, secondary na yun, no? How do we prepare for such things? So, dyan papasok ang DRR, disaster risk reduction. So in terms of public health, dyan papasok yung ating mga politicians. And in terms of construction, dyan papasok ang mga emergency. And then, dyan din papasok yung mga local officials natin. Emergency shelter, dapat meron tayong evacuation center. And then you have mutual help. Meron tayong community evacuation plan and drill. Tapos yung self-help, ano yung gagawin natin within the family, within the house. Yan. Dapat prepared tayo in cases of emergency. Dapat meron tayong supplies, meron tayong flashlight, meron tayong battery, pagkain, sardinas, tubig. Okay. As such, also, meron din dapat tayong evacuation plan. Yan. Mga maps kung saan pupunta. Ano tong evacuation area na yan? Usually, this is an open area. No? Open area. Meron akong nakikitang mga locations yung gaya yung ano ba to? Sports complex, naging evacuation area yun. Yung rice field na hindi na ginagamit, kinawaring evacuation. Okay? And then we have safe zones. Number 1, you have understudy tables. Yan yung number 1 rule kapag na-stuck ka sa loob ng building. Kapag nag-earthquake, pumunta ka sa ilalim ng table. Tapos, another question. What is the safest place to go in times of earthquake? Sa taas ba ng building? O tumakbo ka pababa ng building? Yan. Safe zones, you have columns and beams, load-bearing doorway or wall, outside elevator shafts, and open clear area. So, these are considered as safe zones. And why are columns and beams considered as safe zones? Kasi yan yung mga seismic resisting components ng building. Okay? Diyan na-transfer yung mga forces, lateral and vertical forces. And then, danger zones. Ayan, windows and glasses. Yan yung mga nahuhulog ng mga bote sa salamin. Then you have bookshelves, cabinets and furniture, hanging objects. Those are danger zones. And inside elevators. Power lines. Ayan, pag naputol yung power line, baka may makuryente. And then bridges and flyovers. These are considered danger zones kasi kapag nagkaroon ng liquefaction, lumalambot yung substructure to the point na magko-collapse yung structure. And then before the earthquake, okay, dito again papasok yung ating preparedness. You have emergency kit, survival kit, things like those. And what to do during earthquake? You have to drop, cover, and hold. Drill yan, ano? Drop, cover, and hold. And then you have preparedness activities. Ayan. Merong mga LGU, gumagawa sila ng drill. Meron silang, nagkakaroon sila ng community planning. Meron silang evacuation map. So pag meron din silang ginagawang mga, practice, Now, for the summary of the entire lecture, so it boils down to movement of the active faults and trenches can generate large earthquakes which can significantly affect cities and towns. Period. Yan. Hindi ko na na-edit ito. And then we need to understand and appreciate the hazards and risks to prepare and respond appropriately. Itong summary na yan, ang designed audience nito, yung mga DRR people, mga politicians, and then the community. Okay? So this summary, hindi yan ang audience niyan, hindi para sa atin. Okay? In terms of engineering, as engineer, para sa akin, ang summary ko niyan, ang earthquake, totoo yan, and we should be educated enough to design buildings that is safe and that i-anticipate natin na yung building natin ay safe sa magnitude 7 or 8 or type A building or type A seismic activity. Okay guys, so thank you. This presentation was prepared by pbolx.dost.gov.ph. Silang original na gumawa nito. Kinopya ko lang yan actually. And this is also presented originally by Professor Dr. Renato Yus Solidum. Siya ang director ng PHIVOLX. This is from mainstreaming disaster risk reduction into the local development planning process, contingency planning, and emergency preparedness through the use of the REDAS software. This is from March 2019. And also from Julius Galgiano from October 24, 2016 at Batac, Ilocos Norte. By the way, I was also one of the presenters here sa Batac, nung October 2016. Ang present ko dito naman nun ay preparing hazard maps. Okay guys, so that's it. That ends our first lecture.